Welcome back, everybody. Here goes a video on synthetic division. Now, synthetic division is actually a form of factoring. It's very similar to long division, which you use when you have a given solution or factor of it. But synthetic division is much easier, quicker. The only downside is it doesn't always work. So before you say, how come you showed us long division, this way is way better, you need to know that it doesn't always work. So there's a couple of ways I've seen synthetic division done. Some people just use a little backwards L and you put a 2 in the corner, but I like to do a bigger one just to help keep your work organized. So the first thing we're going to do is we're going to put a 2. Now you're probably wondering where I got the 2. The 2 comes from what you're dividing by solution. So x minus 2 is equal to 0, so x is equal to 2. So you put the solution to what you are dividing by in front. And then inside you put just the leading coefficient of each term. So we have a 2x cubed minus 3x squared plus 1x minus 4. Okay? And now the magic is about to happen. The first thing you have to do is bring down the 2. And then you multiply. So you do 2 times 2, and you put it over here. And it's 4. So 2 times 2 is 4. And then you add those together. So when you're doing synthetic division, it's adding. Negative 3 plus 4 is 1. And then you do it again. 2 times 1 is 2, so you put it over there. And then you add those guys together. 1 plus 2 is 3. One last time. 2 times 3 is 6, so we put it over here. Add those together, and we have a remainder of 2. So our final answer would be, so we started at x cubed, it's 1 below. So it's x squared plus 1x plus 3, and a remainder of 2. Now, just like long division, you don't want a remainder when you are actually going through and factoring. But if we're just dividing, then it's okay. And then, of course, you would say the final answer is 2x squared plus x plus 3 plus your remainder over what you are dividing by. Okay? But just like the remainder theorem of long division, if you have a remainder, x minus 2 is not a factor of 2x cubed minus 3x squared plus x minus 4. So you want there to be a final number of 0 when you become, or when you are about to factor. Okay? So keep that in mind. So now we're actually going to go factor. So we're going to do this question, and you might say, well, why don't I just group it? Well, you can try grouping this, but you can't factor out anything other than an x squared here, leaving you with 2x plus 11. And over here, after you factor out a 9, you have 2x plus 1. So the insides are not going to be the same. So remember, that is one of the main rules of grouping. What you have inside must be the same. In this case, it doesn't work. So you use synthetic division. So you drop your big ol' L. You have your 2, 11, 18, and 9. And x is equal to a negative 3. We already gave you that. So you drop your 2. Negative 3 times 2 is a negative 6. 11 minus 6 is 5. Negative 3 times 5 is a negative 15. 18 minus 15 is 3. Negative 3 times 3 is a negative 9. And hooray, we have no remainder. So that means negative 3 is a solution to this. So one of our factors is x plus 3. You have to remember where negative 3 came from. So it came from x plus 3. So now we have 2x squared plus 5x plus 3. And if we're going to continue factoring, we're going to put it over here, 2x squared plus 5x plus 3, we can continue now. This can be factored using splitting the middle term. So you have 6x squared, which splits to 2x and 3x. Bring down your 3, bring down your 2x squared. Factor out your GCF of 2x, leaving you with x plus 1. GCF of 3, leaving you with x plus 1. So your final answer is x plus 3. Don't forget about where the negative 3 came from. And then your 2x plus 3 and your x plus 1. So that's how you use synthetic division. Again, it is a form of factoring, but it actually can be used for just about everything as long as it goes in evenly. However, it's a trick that doesn't always work, so that's why you still have to know long division just in case. Now here's a very similar question, but this time we're finding the other zeros. Remember, zeros also means solutions. So basically that's a fancy way of saying, go solve this. So we have one solution of 2 that was given to us. Drop the big L. And then we have a 1, negative 2, negative 9, and 18. Bring down the 1. 2 times 1 is 2. Add those together, you get 0. 2 times 0 is 0. Negative 9. 2 times a negative 9 is negative 18. Hooray! No remainder. So that is a factor. So we start one below. So x squared, x, constant. So that's going to give us x squared minus 9. And then, of course, we already had the x minus 2. We don't need to write that because we're finding the other zeros. We know one of them is 2. You just have to factor this, x plus 3 times x minus 3. So our other zeros are a negative 3 and a positive 3. So all of our solutions are 2, negative 3, and positive 3. Okay, and again, whenever they're nice and pretty like that, you can just go check that on a graphing calculator. You can type this into Y1 of your graphing calculator and it'll pass through those 3 spots. The other thing you could have done is you could have done this one by grouping. If you would have factored out an x squared and a negative 9, you would have gotten the exact same answer. However, this is just to show you that it's another skill. You can use synthetic division to factor almost everything as long as you have one nice 0. All right, that's it for this video on synthetic division. This is Longo and I'm out. See you, bye.